Okay, there's a question about how to name alkyl, name amines, as in like question number 71. In another question, I went over quickly how to name amines using problem 70 as an example, and I'll do it again here. So as we look at this molecule, I see an alkene and I see an amine. So I go to my chart, and my chart says that an amine has a higher priority than an alkene. So again, having that higher priority means that it will get preference in the numbering of the longest chain, and it will come at the end of the list of suffixes. So looking at this molecule then, the way we look at amines is that we choose, number one, for amines, we look at the three groups attached to the nitrogen. The longest becomes the parent chain. Okay, so looking at this molecule then, the first one, it's got a methyl group, it has an ethyl group, and it has this chain. And so that chain, this chain is going to be the longest carbon chain, and so this is going to become the parent. Okay. Now, what do we do with the other chains? The others become substituents, and the groups get an N prefix. But other than that, they become substituents. They become substituents in the longest parent chain. And that's how we're going to name them. So looking at this parent chain then, this group right here this is going to be an N, what's called an N-ethyl, and this group right here is going to be called an N-methyl. Okay? So basically the N replaces the number of the group. So when we see an N-ethyl group, it means that that ethyl group is attached to the nitrogen of the amine. The same thing would be true for the N-methyl. So if I make a list of substituents, I have an N-ethyl group and an N-methyl group alphabetized, because the N is hyphenated, as E and M. So now I'm just going to go ahead and name this as a normal alkene. So I'm going to take this and I'm going to number from the N closest to the nitrogen, because the nitrogen has precedence. So in this case, it's going to work out good for the alkene. Carbon 1, carbon 2, 3, 4, and 5. So this is going to become then a pent. And it's going to become a pent 1-ene, because the alkene starts at carbon 1. Now the final suffix here is going to be the amine. Where is it located? It's located on carbon 2, and so the overall sort of parent name here with all the suffixes is going to be pent 1-ene 2-amine. So again, total number of carbons, the 1-ene is whether there's an alkane, alkene, or alkyne. If there's an alkene or an alkyne, the number comes before that to tell where it is. If this was all single bonds, it would be a pentane 2-amine, and then the 2-amine, because the amine has precedence, has the highest precedence on the chart. So we only have two we don't have two substituents here. We have 3 substituents because we have a methyl group at carbon 3. So we also have a 3 methyl group. Now the interesting thing that happens here is I combine the 2 methyl groups, and since the N is replacing the number basically of where the methyl group is, this becomes an N3 dimethyl. It might be 3N dimethyl. I'm not too concerned about that. So this would be an N3 dimethyl, and then we have an N-ethyl, which comes first alphabetically. So the name of this molecule then, I'm going to list and write my substituents. So I'm going to have an N-ethyl based on E, an N3 dimethyl, pent, 1 ene, 2 amine. And so that would be the name of that molecule. And let me just double check here to make sure if it's 3N or N3. It's N3. So N comes first. So again, looking at this name, I've got a 5-carbon chain, a double bond between carbons 1 and 2, an amine at carbon 2, and attached to that amine is an ethyl group and a methyl group, and then there's also a methyl group attached to carbon 3. Okay? So that's kind of how we go through and deal with amines. So let's take this structure, since I didn't give myself enough room, and let me rewrite it here. Okay, so this is number B. This is letter B, so what would its name be? So again, I look at the nitrogen. I've got an ethyl group, so this is going to become an N-ethyl group, simply because this then is going to become my longest chain, because that's the longest alkyl group attached to the nitrogen. It looks to me like I have 2 methyl groups here, so I'm going to end up with a dimethyl. So now let's look at the numbering scheme. And again, the numbering scheme favors the highest priority substituent, or highest priority functional group, which in this case is the nitrogen. So this is going to be a 1, 2, 3, 4, 5. So this is going to be a 3, 4 dimethyl, as are these 2 substituents, and then I have an N-ethyl group for the ethyl attached to nitrogen. Alphabetically, N-ethyl is going to come first, so this is going to be an N-ethyl 3, 4 dimethyl, and then the total number of carbons in this case is 5, so this is a pent. Is it an alkene, alkane, or alkyne? It's an alkene, so we put the number in of 3-ene, and then the amine is at carbon 2, so it's a 2-amine. So N-ethyl 3,4 dimethyl 1 pent 3-ene 2-amine is the name of that. And that one is, I believe that is number D. So this is letter D, the name that's given in problem 71. Okay? So here are the last two. If you're an overly ambitious go-getter student, you could stop the video right now and do these names and see if you get them correct. If you still need a little bit of help, I'll walk you through the last two. Okay, so looking at this is letter C. Looking at this, I'm going to again look at my nitrogen, and that's going to make this. This is the longest group, so that's going to become the parent chain. Up here I have two methyl groups, so this is going to become an N dimethyl, indicating that the two methyls are attached each to nitrogen. You can't have a one dimethyl, you need N to show that the two methyls are attached both nitrogens. Then it looks to me like I have a methyl group here and a methyl group here. So I'm going to actually have an NN and then two numbers tetramethyl as my substituents, but let's work to that. Okay, number from the end closest to the highest priority functional group, which in this case is amines. So we have to number 1, 2, 3, 4, and 5. So I've got a 3,4 dimethyl as substituents and an N dimethyl. So what I'm going to do is I'm going to combine those together to have an N 3, 4 tetramethyl. Pent. Total number of carbons is in an alkane, alkene, alkyne. It's an alkene, so 4-ene. Where's the amine located? Carbon 2. So this would be NN 3,4 tetramethyl pent 4-ene to amine, which is answer B, or letter B, or name B, I guess. Okay. Let's wall this one off. Okay, how about the last one? This is structure D. So in this case, I just have an NH2. So that's going to make this automatically the longest continuous carbon chain, except I need to, if possible, then I need to include the longest chain that includes a double bond. Okay, since it's a secondary priority. So I have it. I'm going to number from the end closest to the nitrogen, which is going to make this 1, 2, 3, 4, 5, 6. So now we've got a hex. It looks to me like I have a methyl group at 5, a methyl group at 4, and a methyl group at 2. So this is going to be a 2, 4, 5 trimethyl. And then total number of carbons is hex for 6. Is it an alkene, alkane, alkyne? It's an alkene. So where's the double bond at? It's a carbon 1. And then where's the amine at as the highest priority functional group? 3 amine. So 2,4,5 trimethyl hex 1 ene 3 amine. 2,4,5 trimethyl hex 1 ene 3 amine. What did I do? Yep, we're correct. So this one is letter C. It was named C, I guess. Okay. So that's how we name the amines using their systematic approach.